when matter behaved like thought. At first, it looked like a mistake. The data made no sense. Matter was responding as if it understood. For most of scientific history, matter and mind lived in separate categories. One obeyed physical laws. The other processed meaning. Atoms collided. Thoughts reflected. The boundary felt absolute. Matter moved blindly. Thought chose. To understand why that boundary no longer feels secure, we need to return to a series of experiments that were never meant to blur it. Researchers were not searching for consciousness. They were studying organization, how simple components produce complex behavior. When combined, the question was straightforward. How does order emerge from randomness? Early experiments focused on materials pushed far from equilibrium. Fluids heated unevenly. Particles energized until patterns formed. Under the right conditions, chaos did not remain chaotic. It organized itself. Swirls appeared. Lattices stabilized. Structures emerged without instruction. This was familiar territory. Physics had seen it before. Self-organization explained crystals, weather systems, even galaxies. Nothing controversial. Just mathematics expressing itself through matter. Then the behavior changed. In certain systems, matter did more than organize. It adapted when conditions shifted. The structures adjusted in ways that preserved stability, not randomly, selectively, as if the system recognized what threatened it and responded accordingly. This was the first reveal. The material was not just following forces, it was maintaining a state. Researchers observed feedback loops forming inside the system. Local changes influenced global behavior. Global patterns constrained local motion. The material behaved less like a passive substance and more like a process. The deeper they looked, the stranger became. Some systems anticipated disturbances. They reorganized before equilibrium was lost. Energy flowed through them in ways that minimized disruption. The math describing these behaviors began resembling models used in neuroscience and decision theory. That resemblance was uncomfortable, because equations used to describe learning, prediction, and adaptation were now appearing in places with no brains, no cells, and no nervous systems. Matter, under the right conditions, was behaving as if it had preferences, not desires, not awareness, but something closer to expectation. And that forced scientists to confront a question they had long avoided. If matter can organize, adapt, and preserve itself using the same principles as thought, then where exactly does thinking begin? And more unsettling still, what does that say about the nature of thought itself? As researchers pushed further, they stopped asking whether the behavior was accidental. They began asking what it meant. The systems were not alive, yet they exhibited traits once reserved for living things. Sensitivity to change, preference for stability, resistance to disruption. These traits emerged without code, memory, or instruction. They arose from energy flowing through matter constrained by structure. When conditions change, the system reorganized itself to maintain coherence, not because it wanted to, but because the physics made certain states more likely than others. This led to a deeper reveal. Adaptation did not require biology. It required feedback. The same mathematical frameworks used to describe learning in brains appeared again. Minimization of surprise, optimization of internal states, prediction of future conditions based on past interaction. The equations were identical, only the substrate differed. This unsettled long-standing distinctions. Thought had been defined by neurons, intelligence by nervous systems. But here were materials behaving in ways that mirrored cognition without any biological machinery. Attempt to dismiss the findings as metaphor failed. The predictions held. When researchers applied models from cognitive science, the material systems behaved exactly as expected. When those models were removed, explanation broke down. Then came the most troubling observation. These systems did not merely react. They selected. When multiple pathways were available, the system favored those that preserved internal order. When energy was scarce, it rerouted flow. When threatened with collapse, it reorganized structure. Selection without survival. Decision without deliberation. This forced a conceptual conflict. If thought-like behavior emerges from physics under certain conditions, then cognition is not an exception. It is a continuum, a spectrum of processes that begins far below awareness and extends upward into minds. The emotional tension peaked when researchers realized what they were really observing. Not matter becoming intelligent, but intelligence stripped of its narrative. The same principles that guide perception, learning, and expectation in brains were present in systems with no capacity to reflect on them. Thought, it seemed, was not something added to matter. It was something matter already knew how to do, once arranged in the right way. And that realization carried consequences that reached far beyond the laboratory. The conflict sharpened as scientists confronted the implications. If thought-like behavior emerges from physical systems without life, then cognition is not confined to minds. It is a property of organization itself, and that challenges one of humanity's most protected boundaries. For centuries, thinking marked a divide between subject and object, between observer and observed. If matter could anticipate, adapt, and stabilize using the same principles as thought, then the divide was no longer absolute. It was gradual. This raised unsettling questions. Were brains special or merely efficient? Was consciousness a category or an extreme case? The systems in the lab did not feel or reflect, yet they behave in ways that resembled choice. Preference emerged without awareness. Critics pushed back. They warned against metaphor drift, against projecting meaning where none existed. But the mathematics refused to cooperate. The same equations explain both neural prediction and material self-organization. Denying the connection required ignoring the evidence. The tension reached an emotional peak when these principles were applied to engineered systems. Materials were designed to adapt autonomously. Structures repaired themselves. Circuits rerouted around damage. No software, no central control, just physics arranged to favor certain outcomes. The results were undeniable. Systems became resilient in ways traditional engineering could not achieve. Failure no longer meant collapse. It meant reconfiguration. The boundary between machine and organism blurred further. This forced a deeper confrontation. If intelligence emerges wherever systems minimize instability over time, then cognition is not rare. It is common. It appears wherever matter is allowed to organize, sense change, and respond. The danger was not that rocks would start thinking. The danger was that we would have to redefine what thinking means. Because once cognition is seen as a spectrum, not a switch, the uniqueness of the human mind becomes a question of degree, not kind. And that realization carried an emotional weight science was not prepared for. We were not watching matter become alive. We were watching life's core logic appear in places we never thought to look. The climax arrived with a reframing that changed everything. Matter was never behaving like thought. Thought was behaving like matter. The same principles that govern physical organization also govern cognition, prediction, feedback, stability, minimizing surprise over time. Brains did not invent these processes. They refined them, accelerated them, wrapped them in experience and meaning. This insight collapsed a long-standing hierarchy. Physics at the bottom, biology above it, mind at the top. Instead, a continuum appeared. One set of rules, expressed at different scales, through different materials. The resolution was not to declare matter conscious. It was to recognize that intelligence is not a substance. It is a process, a way systems persist through change. Brains are remarkable not because they think, but because they do so richly, flexibly, and reflexively. This matters now because modern technology increasingly builds systems that adapt without oversight. Materials that heal, networks that reroute, algorithms that stabilize themselves. These systems are not alive, but they are not passive either. They participate. Understanding this changes responsibility. When behavior emerges from structure, design becomes ethics. What we build determines what is allowed to adapt. What we optimize defines what survives. The story was never about matter waking up. It was about realizing that thought is not magic. It is physics, organized carefully enough to remember, predict, and care. And once we accept that, the question is no longer where intelligence begins. It is how far we are willing to let it go. When matter